This is section 10.1, part 2. I've worked some of these problems out already, so I just want to walk you through what we've done. When we're graphing a parabola, we want to graph at least 5 points on the graph, if not more. So let's look at this first example that I've done here. We have the problem 1/2 x squared. So I started with the value of 0. I plugged 0 into 1/2 x squared to find my value of y, and I got 0, 0. So I plotted that point here in blue. I now chose 1, 2, and 3, and I plugged those values in using parentheses to find my other values, 1/2, 2, and 4.5. Realize when you square 3 you get 9, divide it by 2, and you get 4.5. So I plotted those 3 points on my graph. From that point, I tried one more point, -2, and I plugged it in, and I saw that it was right across from my +2 value. From that I can easily see that this graph is symmetrical, and so I plot my other points symmetrically across from my graph points that are already there. I can then draw my line, or draw my parabola, making sure to put arrows at the end of each one. Now let's look at the bottom one. This graph is y equals x squared minus 3. As you've done more and more of these, you'll begin to see the plus or the minus at the back end of the graph when there's just an x squared shifts it either up or down. Well, in this case, the whole graph will be, a normal graph will be shifted down 3 units. So once again, I tried 0, 1, 2, and 3, and I plugged my values in, and I got these values here at the right. I plotted those points here in blue on the graph, and then I checked another point, and in this case I checked -1. Notice when I plugged in my negatives, I used parentheses to do so. I subtracted 3, and I got -2. And so that point was exactly across from the other points. From that idea, then, I reflected all of my blue points to my red points on the other side, and I graphed the other side very successfully. This reflective nature is very characteristic of a parabola.